Welcome to all to class number 68. If you remember, in class number 66, we solved these two questions by systematic approach or basic approach. We even proved what is the variation of SF and VM. Then class 67, I did this question with changed numerical when x was from A. That deliberately to understand the principle, that is how to consider trapezoidal load. Now, in class 66, I told one more class will be there for this one where I will solve these two by shortcut. That is easier approach. Okay, now start. You refer class number 66. If you are following all my classes, you will be knowing what is going on. So start this question. Calculate support reaction. Already explained for you. So I won't waste time. This has been now done so many times earlier that if I explain further, it will be unnecessary dragging or time waste only. So those who are serious will go through all the previous classes and understand that is uniformly varying load. First we started this way, then this way. This is the last part of this uniformly varying load with 0 at one end and maximum at the other end. Okay. We get the reaction, moment about A minus VB into L plus the total load is here. Total load here. Half into L into W into 1/3 of L equal to 0. VB will come. Sigma V0 VA. Now go for SFD BMD. See, beam is ready here. Enter everything. Project down. See what I am doing. Go up by WL by 3. See. From here to here, come down by half into L into W. That is WL by 2. Already told so many times, it will become WL by 6 minus, so minus negative here, WL by 6. Okay. Parabola. This explained so many times here. Maximum slope here, where intensity is maximum. Zero slope here, where intensity is 0. It will cross the baseline here at a point X. Now, anyway, just to see that question also satisfies academic requirement, I have shown shear force calculation. Shear force at A, slightly inside, look this side, plus WL by 3. Shear force at B, come slightly this side, look that side, minus WL by 6. Reason is known for you. Then, to locate the point where SF equals 0, let SF be 0 at a point X, at X from here. Forgot to write the X there, I write here. This is X. That entry is later, not now. The entry will make later after getting the answer. Okay, now at X from here, a separate sketch here, get the intensity. Then shear force here, look that side. It is minus WL by 6 plus half into X into WX by L equal to 0. You get value of X, L by root 3. Earlier question when the UL was this way, it was L by root 3 from left hand. Now L by root 3 from right hand. Next, BM calculation. BM at A0, BM at B0. Also find BM at this point. See, at this point find BM. WL by 6 into X minus half into X into WX by L is the total load into 1/3 of X. Load will be acting somewhere here. This substitute X equal to L by root 3, simplify, get the answer, neatly draw SFD and BMD. This all explained many times. So now onwards, which are repetitive, which concepts or which principles thoroughly told earlier, I will skip in the class, because if you want to study thoroughly or understand thoroughly, you should go through everything. Okay, now I will complete it by solving this question. Again, I will write everything and explain. Sufficient. Now, the second question, numbering is already there. Their total is given 75 kN. Therefore, you have to get the intensity here. Let W be the maximum intensity. Half into 6 into W equal to 75. You get W. Enter that value. Take moment. Minus VB into 6 plus half into 6 into 25, or directly how much? 75 into 1/3 of 6 equals 0. VB will come. Sigma V0, you get VA. Neatly enter the values here. Everything is ready for SFD BMD. Start. Shear force calculation. Shear force at A, look this side, plus 50. Shear force at B, that side, minus 25. So plus 50 minus 25, This is a shear force diagram. It will cross the baseline at x. Locate that point by first getting intensity here in terms of x. 25 by this length equal to, actually length is not required, right? Okay, still I will write 6 meter. 25 by 6 into x is the intensity there. Then shear force equal to minus 25 plus half into x into 25 by 6x should be equal to 0. Get the value of x. Then x we got. Or you know the formula L by root 3. You can check it later. BM calculation. BM at A0, BM at B0. Also find BM at this point x where shear force is 0, which is the maximum BM. I written there. Now if you cannot understand, there is no, I will tell no point in going through my classes. As I told from beginning, every class thoroughly you will understand, then only everything will be clear. Because see, so many times when it is repetitive, I will not explain too much. Some work is there for you also. If you want to learn and get knowledge, you have to put some effort. Somebody will comment, suddenly come to this class, tell, nothing is done here, just simply solved. Okay, let them put the comment. They are not the people who are interested in knowledge. They came for time pass. My class is not for time pass people, or for people who want to go through some class just for time pass. Rigorous study and thorough knowledge, both will go together. Okay, now completely over. Go through, solve correctly, shortcut. See, earlier I took a section XX, then got the expression. That all not required. Easily, shortcut I told. I forgot to tell one thing for this one also. You have to always write SF variation for UVL, parabolic second degree, BM variation, parabolic third degree or cubic curve. That you have to write. Okay. Now we will meet in class number 69, where I will take the last two cases of this one. See, Roman 5.2. One of them is this way, bookwork and numerical. Then second one, because these are asked for competitive examination, this way. Once that is over, then we will go for, I think, either I will go for couples or I will go for UVL with point load and UDL, combination of loads. There, any number of problems possible, I will try to cover maximum possible so that everything is completely clear. This is not required now. Okay. Thank you. We will meet in the next class, class number 69.